Looking at page 23, more instances in which U substitution is involved. You see something like number 5 is very consistent with what we've been doing before. You see we got this big beefy expression in the radicand in the denominator. So we'll try making that our U. So we'd get 2x minus 8 dx. Well, that's good because that's just a constant multiple away from being x minus 4. So I'm going to pull out a 2. And you see here, aside from this replacing the u, we would have this replacing the x minus 4 dx as long as that 2 goes away. So let's make that 2 go away. So 1/2 du would be equal to x minus 4 dx. Alright, so now I can do my substitution. And it's going to be 1/2 du over the square root of u, much simpler. Now I'm just going to rewrite as 1/2 u to the negative 1/2 du. Increase the exponent by 1. Oops. Divide by the new exponent, which is just going to zap away that 1/2, plus c, and then replace the u with what it was originally, x squared minus 8x plus 1 to the 1/2 plus c. Alright, so not too bad. For number 6, there's a bunch of different ways that you can do it. One way actually relies on you knowing what the antiderivative of secant is, and if you know the antiderivative rule for secant, then you're in good shape. What I'm going to do is just kind of take this opportunity to show you where the antiderivative rule for secant came from, so I'm just going to kind of do that as a quick aside. So let's say we have the antiderivative secant x dx. In order to find the antiderivative of this, what we would actually have to do is create a u substitution situation. And the way we handle that is by multiplying, and you'll see as we go forward through the course that there are some clever strategies that kind of come into play. Some things that, you know, maybe you don't necessarily think of until you see it demonstrated, and then it opens a whole world of possibilities. All right, and this is one of them. So we would multiply the top and bottom by secant x plus tangent x. All right, and when you multiply through with the secant, you get secant squared plus secant tangent. On the bottom's going to stay put because when you multiply by, you know, a fraction by a monomial, it's really that monomial over 1. So this is over secant x plus tangent x dx. Now what I'm actually going to do is just rewrite it, very subtle change. I'm just going to, because addition is commutative, swap the order in the numerator. And so I'm just going to move some things around here. The reason why I'm going to do that is because it's actually kind of nice if I let u be equal to secant x plus tangent x, du, if you take the derivative of each part separately, becomes secant x tangent x plus secant squared x dx. So we get actually a nice clean substitution, which, you know, you don't necessarily always see coming when you start embarking on a journey like this. Journeys. Alright, so just kind of, I'll fix that in a little bit. So we're looking at just a du over u. Now that could also be written as 1 over u du, which is the natural log of u plus c, which in turn, because u is secant x plus tan x, would be the natural log of secant x plus tan x plus c. I like going through this approach because it's u substitution, so it ties in nicely with what we're doing, but also it's a rule, so it's kind of like u substitution that doesn't necessarily need to happen because you can just rely on the rule. Now, what we're looking at in number 6 is secant of 2x. All right, so this is what I call baby u sub. All right, so if it's just an x, then it would be the rule, but it only differs by a constant multiple. All right, so it's u substitution, but only on the most minor level. All right, so I would let u equal 2x. Du is equal to 2 times dx. All right, so when I make a substitution here, I'm looking at secant of u, but I only need to swap out a dx, so let me get rid of this 2. This becomes 1/2 du equals dx. So times 1/2 du. All right. So I'll rewrite 1/2 secant u du. Antiderivative of secant x is natural log of secant x plus tan x plus c. Well, this has got a u, so it's the same idea. All right. So secant, oh well, I forgot my ln. ln of secant u plus tangent u. I got my 1/2 and I got my plus c. So 1/2 ln of secant 2x plus tangent of 2x plus c. So it's kind of a nice little outcome there where you didn't have to do all of this to find the antiderivative of secant, even though it's an implied u substitution. It's also a rule, so you get away with it. You also kind of didn't really need to do the u substitution for the 2x, because if you know it's just a constant multiple away from being the antiderivative, it's just a matter of coming up with that correction factor, which is usually 1 over whatever the coefficient is of the x value. All right, so once you have that, then you're in pretty good shape. All right, so number 7, you got choices here, because when we decide on what's going to be the u, we usually look for the expression that when differentiated will help us cancel out whatever we don't select as u. All right, well, the derivative of sine is cosine. The derivative of cosine is negative sine. So in a way, each possible choice will help us cancel out the other to some extent. All right, but we want a complete cancellation. All right, if I take sine as my u, the derivative of sine is cosine. That's not going to help me cancel out cosine squared. All right, so I'm going to let u be equal to cosine of x. Du would be equal to negative sine x dx. All right, so then since I don't need to cancel out a negative sine x, I need to cancel out a sine x. I'll negate the whole thing. Negative du is equal to sine x dx. All right, so cancel. I guess I gotta increase the size of my highlighter again. Cancel, cancel. All right, so this is gonna wipe out the cosine. So we're looking at u squared times negative du. So negative u squared du, integrate negative 1/3 u cubed plus c, and then bring back the u, which is cosine. So negative 1/3 cosine cubed x plus c. All right, so not too bad, provided you select the right u. If it seems like I'm saying that over and over again, it's not too bad as long as you select the right u, then there might be something to that. All right. Number 8 has a star. Trying to remember why. I'm pretty sure it's because it's kind of along the same lines as number 6 in that it involves a rule. So it kind of is the case that number 6 should also have a star, because you could make use of the rule or not, and that'll impact the level of difficulty of the problem. All right, so here I would let u be equal to 4x squared, because I see very quickly that the derivative of 4x squared is 8x, and that would help us cancel that out. So du is going to be 8x dx. All right, so that's good news. So we're just looking at a nice clean antiderivative of tangent u du. The issue here is if you don't know the antiderivative of tangent u, then you're in a jam. All right. So same idea as number 6. I'm going to take you through how you can figure that out, but just knowing that it's also a rule. All right. So just kind of off on the side, coordinate off here, and I'll just do it as y and x. All right. Well, I guess I don't need the y, but antiderivative tan x dx. We could rewrite that as sine of x over cosine of x. If I let u be equal to cosine of x, du would be equal to negative sine x dx. So almost a clean cancellation. If I negate both sides, then I have it. All right. So I could cancel this part, and this is my substitution, so everything's accounted for. That's why I like the highlighter. If everything is highlighted when all is said and done, then I'm pretty confident that I got all my substitutions right. Yeah. That being said, before I had the ability to do this digital inking, I never had a highlighter approach because I didn't want to carry around highlighters. The fact that it's built into this app is what makes me want to do it. So if you haven't considered getting an app and trying to do it with a stylus, or I prefer the Apple Pencil, but I know it's a little pricey. You know, it might be worth looking into, but it's up to you. I know, like I said, I know it's pricey. All right. So we're looking at negative 1 over u du. Antiderivative of 1 over u du is ln of u. So negative ln of u plus, and I did not give myself enough room. I could kind of smidge it over. Plus c. All right, now the u is cosine. So negative ln of cosine x plus c. And this is where you can kind of get a little cute with it, because coefficients become exponents in logs. So I could write this as ln of cosine x to the negative first plus c. When you raise something to the negative first power, you're taking the reciprocal. Reciprocal of cosine is secant. So ln of secant plus c. The benefit of writing it this way is you're not working with a co-function. All right, co-function is anything that has a co on it. You're working with a unique secant function, but also we don't have any constant multipliers. All right, so it's kind of nice in that regard. All right, so you wouldn't have to do all this if you know the rule. So I mean, if that's motivation for you to get to know a rule, then at a minimum, I've done my job there. But you could see that, yeah, definitely not too crazy in terms of, especially if you have experience with a lot of this integration stuff from, previous experience, like whether it's AP calculus or maybe you took this course previously, for whatever reason. It gets harder. So any corners you can cut along the way legally is going to be a good thing. All right. So we're looking at ln of the secant of u plus c, where u is 4x squared. And there you go. Looks like maybe the denominator is probably the way to go when selecting a u, but the problem with that is it looks a little messy in the sense that, I mean, yeah, I could let the x cubed, I guess, be u, but then I got to do some other things there. But it might be worth it to try to do some algebra to it first and see if it's factorable. You could actually get away with, there is a pathway to getting it correct if you let u equal x cubed first, but let's just do it this way. All right, so it is factorable as a perfect square trinomial. All right, so 4 minus x cubed, 4 minus x cubed. All right, the outers each give you 4x cubed negative. Put them together, and you get negative 8x to the third, so we're good there. All right. So what we can do is we can let u be equal to 4 minus x cubed, where du would be equal to negative 3x squared dx. And if I just want an x squared, I'm going to multiply both sides by negative 1/3 and get the x squared dx. So that makes things a little nicer. So we got the clean substitution there. And we got a substitution for each of these. Alright, so we're looking at negative 1/3 du over the square root of u times u, which is really just a u. Alright, so the integral of negative 1/3 times 1 over u du is going to give us another natural log. So negative 1/3 ln of u plus c, where the u is 4 minus x cubed. And that would be it. And let's see what we can do with perhaps that denominator. Let u equal 1 plus e to the negative 4/5 x, in which case du would be equal to negative e, well, I'll write the e to the negative 4/5 x part first, times the negative 4/5. Alright, because it could be, you could also write it as negative 4/5 e to the negative 4/5 x. Don't forget your dx. I didn't give myself enough room, of course, as usual. Just tuck it in right there. Alright, so looking at the numerator, I think we're in pretty good shape here, because I have a negative 4/5, and I have a negative e to the negative, I'm sorry, e to the negative, I keep wanting to say negative e. E to the negative 4/5 x, I just have that extra negative 1 there, so I can account for that in a sec. And it looks like on the bottom, yeah, it's just that clean substitution. It'll be u to the second power. Alright, so, yeah, so we have this, this, and this that can go away. And if anything, we could just leave that negative 1 there and have negative 1 times du over, oh geez Louise, over u squared. So negative u to the negative second du. Increase the exponent by 1, divide by the new exponent. We'd be looking at u to the negative first plus c. So I would write this as e, oops, looking at the wrong thing, 1 plus e to the negative 4/5 x to the negative first power plus c. If you want, you can write it as 1 over 1 plus e to the negative 4/5 x, all of that plus c. Either way would be fine.